name is Mr. Chuen. You are welcome to my study room. If today is your first time, then I want to encourage you to subscribe to this channel for more videos. Today's study is finding the equation of a circle when given 3 points on the circumference of a circle. And I want to just use this opportunity once again for those who are visiting here for the first time that I have a number of videos on the equation of a circle already. For example, when the center and the radius are given, when the center and the point on the circumference are given, when the ends of the diameter are given, and so many other videos. I encourage you to watch those videos to get more understanding of what we are doing. But then we are going to concentrate on today's lesson. By the end of this study, I am going to use 3 different methods to find the equation of a circle when 3 points are given on the circumference of the circle. So let's take the very first one, which is method 1, quickly. So method 1 says that if you have a circle with 3 points with coordinates a, x1, y1, b, x2, y2, and c, x3, y3, then what you will just do is that you fix the coordinates of each of the 3 points into the general equation of a formula. I remember saying in one of the videos that whenever you are given a point on the circumference of the circle, you can just substitute the x and y coordinate of that point into the x and y in the general formula or the general equation of a circle to obtain whatever you are looking for. So in this case, we are going to substitute the x and y coordinates of each of the points into the general formula to obtain 3 equations in G, F, and a C. Then after that, we solve these 3 equations simultaneously to obtain the required equation of the circle. So that is just what we are going to do. Let's take the very first example. Question 1 is asking us to find the equation of the circle passing through the point A with coordinate 4, 1, B with coordinate -3, 8, and then C with coordinate 5, 4. So like I said earlier, we are going to be quoting the general equation of the circle, which is x squared plus y squared plus 2gx plus 2fy plus c equals 0. Let's make it equation 1 for easier reference. So this becomes our equation 1. And now we are going to substitute the coordinate of each of the 3 points into this general equation. So let's start with the very first one. Let me just say at the point A with coordinate 4, 1, our general equation is going to be, so whatever we substitute this one for x and this one for y. So we are going to have 4 squared plus 1 squared plus 2 times 4g plus 2 times 1f plus c equals 0. And this will give us 16 plus 1 plus 8g plus 2f plus c equals 0. Rearranging, we are going to get 8g plus 2f plus c equals -17. And let's call this our equation 2 since we have equation 1 already. Then we substitute b. So at b, -3, 8, our general equation 1 will be -3 squared plus 8 squared plus 2 times -3g plus 2 times 8f plus c equals 0. This gives us 9 plus 64 minus 6g plus 16f plus c equals 0. And rearranging and simplifying further, we are going to have negative 6g plus 16f plus c equals, this will give us 73. So we can negative 73. And this is our equation 3. Then we take the third point, which is C, with coordinate 5, 4. So as C with coordinate 5, 4, we are going to have 5 squared plus 4 squared plus 2 times 5g plus 2 times 4f plus c equals 0. And this gives us 25 plus 16 plus 10g plus 8f plus c equals 0. Simplify and rearrange, we are going to get 10g plus 8f plus c equals, this will give us 41, so minus 41, equation 4. Let's rewrite all these three equations together so that we can solve them simultaneously. Here we have our three equations which we are going to be solving simultaneously, and here we can use any of the methods, either elimination or substitution method, to solve, and we will still get whatever we want to do. But I will use elimination method to solve. So I am first going to do equation 2 minus equation 3. So let me just write that equation 2 minus equation 3 will be giving us 8 minus negative 6 will give us 14g. Then 2 minus 16 will give us negative 14f. This is 0, so equal to negative 17 minus negative 73 will give us 56. And let's call this equation 5. Then we can choose any other two again. So equation 4 minus equation 3, that will also give us 10 minus negative 6 give us 16g. Then 8 minus 16 give us negative 8f equals negative 41 minus negative 73. That will give us 32. Let's make this equation 6. So here we just eliminate the c, so we reduce the three variables to 2. Then we can work here further using any of the methods again, and I will use elimination again. In this case, I want to eliminate f. It's easier for me to eliminate x, so I'm going to eliminate x, and that means I need to get the LCM of 14 and 8, and that is 56. So that means I need to multiply equation 5 by 4 and equation 6 by 7. That's what I'm going to do. So equation 5 times 4 will give me 56. G minus 56 F equals 224, and this becomes equation 7. Then equation 6 by 7. That will give me 112G minus 56F equals 224, and this is equation 8. So now I'll be able to make their coefficient the same, so I need to subtract since the signs are the same. So I'll do equation 8 minus equation 7, and that will give me 56G equals 0. Dividing both sides by 56, G will be equal to 0. Then we go and substitute G equal to 0 into either equation 5 or 6 to get F, and it is easier to get F in equation 6, so I will use equation 6. So I will substitute into equation 6. Equation 6 now becomes 16 times 0 minus 8F equals 32. So this is 0. So you get negative 8F equals 32. Dividing both sides by negative 8, F becomes negative 4. So now that we know the value of F and G, we are going to substitute them into either equation 2, 3, or 4. So I will substitute into equation 2 because that looks a bit smaller. So AG, let me go and write that one first. Eight times 0 plus 2 times our F is negative 4 plus C equals negative 17. This will give us 0 minus 8 plus C equals negative 17. So our C will be equal to negative 17 plus 8, and that will give us negative 9. Wow. So that is a very long one. Now we put everything together. So now we are going to put or substitute G equal to 0, F equals negative 4, and C equals negative 9 into equation 1, which is the general equation of a circle. Our equation 1 now becomes x squared plus y squared plus 2, our G is 0x, plus 2, our F is negative 4y, plus C is negative 9 equal to 0. This will give us x squared plus y squared. This is 0, so minus 8y minus 9 equals 0. And this becomes the equation of the circle we are looking for. Wow, that is a very long one, requires a lot of attention. In practice, it is very long, but the most important thing is that you know what you are doing, and that is to substitute each of the 3 points into the general equation of a circle. Then when you finish, you solve the 3 equations. You will get simultaneously to get the values for G, F, and C. Then you go and substitute that into the general equation of a circle. You can use a calculator to verify your answer, but for the sake of SC questions, you need to know how to do this so that you'll be very sure of what you are doing. So this is just method 1. Let's get to the second method and see whether that will be easier to get. Alright, in method 2, we are using the center radius formula. You know the center radius formula? That is just the equation of a circle in the standard form. That's just, so we are going to use x minus a squared plus y minus b squared equals r squared. And here too, we are going to substitute the x and y coordinate of each point into this and simplify to get the values of a, b, and r. So that is just what we are going to do. So let's do that quickly. Let me restate the point. Alright, so we have the coordinates of our points here. We are going to substitute each of them into it to get 3 equations and solve. So let me just use the first point at a. 4, 1. Our equation is going to be 4 minus a all squared plus 1 minus b all squared equals r squared. To expand this using binomial expansion, we are going to get 16 minus 8a plus a squared plus 1 minus 2b plus b squared equals r squared. Simplifying further and rearranging, we are going to have a squared plus b squared minus 8a minus 2b plus 17 equals r squared. This is equation 1. Then we go to point B. So at point B with coordinate -3, 8, we are going to have -3 minus a all squared plus 8 minus b all squared equals r squared. And this will give us 9 plus 6a plus a squared plus 64 minus 16b plus b squared equals r squared. Simplifying further and rearranging, we are going to have a squared plus b squared plus 6a minus 16b plus 73 equals r squared, and this becomes equation 3. Then we go to point C, which has the coordinates 5, 4. So at point C, 5, 4, our equation is going to be 5 minus a all squared plus 4 minus b all squared equals r squared. Expanding using binomial expansion, we are going to have 25 minus 10a plus a squared plus 16 minus 8b plus b squared equals r squared. Rearranging, we are going to have a squared plus b squared minus 10a minus 8b plus 41 equals r squared. Let's call this equation 3. So this is supposed to be equation 2. This is equation 2. Alright. Now just write the equations closer to one another. Then we use them. We solve them simultaneously. Now that we have the three equations here, we are going to now solve them simultaneously. But then it will be easier for us to eliminate r at this time at the first place, because since equation 1, 2, 3 are all r squared, it means we can equate equation 1 and 2 and then maybe 1 and 3 or 2 and 3. So that is just what we are going to do. So I will say equating equations 1 and 2, because both of them are r squared, meaning that a squared plus b squared minus 8a minus 2b plus 17 will be equal to equation 2, which is a squared plus b squared plus 6a minus 16b plus 73, since each of them equals r squared. So by regrouping, a squared minus a squared will be 0, b squared minus b squared will be 0, then negative 8a minus 6a will give me negative 14a, then negative 2b, this is minus, so plus 16b will give me plus 14b, then this will be equal to 73 minus 17, and that will be equal to 56. Let me call this equation 4. Right. Then I equate any two of these again. It can be any of the two. So let me equate equation 2 and 3. Equating equation 2 and 3, it means that a squared plus b squared plus 6a minus 16b plus 73 should be equal to a squared plus b squared minus 10a minus 8b plus 41, since each of them is r squared. Good. So by regrouping, we are going to have a squared minus a squared is 0, b squared minus b squared is 0. 6a, this becomes positive, so plus 10a will give us 16a. Then negative 16b plus 8b will give us negative 8b. And this will be equal to 41 minus 73 will give us negative 32. Let's call this one equation 5. Good. So now we have eliminated our r. Now we can solve equations 4 and 5 simultaneously to get the values of a and b. I would like to eliminate b. So by eliminating b, I have to find the LCM of 14 and 8. And that is 56. So I have to multiply equation 4 by 4, equation 4 by 4, and equation 5 by 7. So equation 4 by 4 is going to give us negative 56a plus 56b equals 224. So this becomes equation 6. Then equation 5 times 7 is going to give us 16 times 7, 112a minus 8 times 7, negative 8 times 7 is 56b negative, of course, then equal to negative 224. That is negative 32 times 7. And let's make this equation 7. And now, because I want to eliminate this and the signs are different, I add. So equation 6 plus equation 7 is going to give me 112a plus negative 56a is 56a. Then 56b plus negative 56b is 0, of course, because that's what we are eliminating. And 224 plus negative 224 is 0. We divide through both sides by 56. Our a equals 0. And we put a equals 0 into equation 6. It can be into equation 7 as well. So equation 6 now becomes negative 56, our a is 0 plus 56b equals 224. 56b will be equal to 224, and our b will be equal to 4. Now that we know the values of a and b, we can go back and put them into either equations 1, 2, or 3. I will choose equation 1 because it is easier to substitute them into equation 1. But anyone who chooses 2 or 3 will still get the same. A is 0, so 0 squared plus our b is 4, so 4 squared minus 8, our a is 0 minus 2, our b is 4 plus 17 equals r squared. And this now becomes 0 plus 16 minus 0 minus 8 plus 17 equals r squared. 16 minus 8 is 8 plus 17 is 25. So we're going to have 25 being equal to r squared. And taking square root of both sides, our r will be equal to 5 units. Therefore, r equals 5 units. Now that we know the values of a, b, and r, we can just go back and substitute them into the standard equation of a circle which we started with to get the required equation of the circle we are looking for. We are going to have x minus 0 all squared plus y minus 4 all squared being equal to r squared. X minus 0 all squared will give us x squared. Y minus 4 all squared using binomial expansion is going to give us y squared minus 8y plus 16. Our r we know already is 5, so 5 squared. Simplifying further, we are going to have x squared plus y squared minus 8y plus 16 minus 25 equals 0. And this becomes x squared plus y squared minus 8y minus 9 equals 0. And this is the required equation we are looking for. And by comparing with the first formula, we can see that they are the same. X squared plus y squared minus 8y minus 9 equal to 0. That shows that we can use this one to get what we are looking for. Let's now move on to method 3. Yeah, so method 3 is going to use an idea that we can remember from geometric construction, which we use to do circumscribed circle, which is to construct a circle to pass through the 3 vertices of a triangle. I'm going to use that idea to explain. So that idea says that if you have any triangle at all, to draw a circle to pass through the 3 vertices of that triangle, you need to bisect at least 2 sides of the triangle, and where the 2 perpendicular bisectors meet become the center of your circle, which will pass through the 3 vertices. That is what I'm going to do here. So I mean, if you join these 3 points to form a triangle, I just put them arbitrarily on the circle without any precision. I just put my ABC on the circle without any precision. So I'm going to join them quickly. That principle or theorem shows that anytime you bisect any 2 sides of a triangle, wherever they meet, the 2 bisectors meet will be the center of a circle that will pass through the 3 vertices. So I'm just going to bisect the side AB and the side BC, and where the 2 bisectors meet becomes the center of my circle. Then I can use the idea of getting the equation of a circle, giving the center and 1 point on the circumference to find that. But here we just have to remember that we are not going to use instrument. We are going to use the coordinate, and I just indulge you to follow me through quickly. So I'm going to get the bisector of AB. Because I know that the bisector of AB will pass through the midpoint of AB, I have to find the midpoint of AB. So let me do that quickly. Midpoint of AB. We are just going to use the midpoint formula, and that will be x1. So here this becomes our x1. Let me just write it so that I don't get confused. So this is x1, y1, x2, y2 here. So the midpoint becomes x1, which is 4, plus negative 3 all over 2. Then the y coordinate will be y1, which is 1, plus 8 all over 2. And that is going to give us 4 plus negative 3 will be 1, divided by 2 is 1/2. Then this is 9 over 2. Alright. That means that perpendicular bisector, when you get it, it will pass through this point on this line. And we are going to find that line will also be perpendicular to AB. So we have to use the idea of perpendicular lines. And 2 lines are perpendicular if the product of their gradient is -1, or the gradient of one of them is the negative reciprocal of the gradient of the other. So we'll just find the gradient of the line AB, then we find the negative reciprocal of that. So gradient of AB, change in y over change in x. So that will be y2 is 8 minus 1 over -3 minus 4. And that will give us 8 minus 1 is 7. -3 minus 4 is -7. So that will give us -1. If the gradient of this line is -1, then the negative reciprocal of this will be 1. So the gradient of the perpendicular bisector, which we are looking for, will be 1. Good, because This is the negative reciprocal of this, or this times this will give us -1. Now we have to go and look for the equation of the perpendicular bisector, since we are not using instruments. So we are going to look for the equation of the line which will bisect this one and will be perpendicular to it. So that will be, we are going to use the idea of finding the equation of a line given the gradient and a point on the line. And here I want to encourage those who have not watched that video of mine yet to quickly watch that one to refresh their mind. The title is what you need to know about the equation of a straight line. So now we are going to find the equation of the perpendicular bisector to this line with gradient 1 and passing through this point, because this point is in the middle and the line is also to be perpendicular to this line. So that's why we got this gradient from this, since the two of them are perpendicular. So now we are going to have our equation to be required equation. So our required equation, y minus y1 equals m into bracket x minus x1. So y, this is our y1 minus 9/2 equals, our gradient is 1 times x minus 1/2. We are going to get y minus 9/2 equals x minus 1/2. Then multiplying through by 2, we are going to get 2y minus 9 equals 2x minus 1. Rearranging, we are moving everything to the right hand side. So we'll be having 2x minus 2y. Then this comes here, positive 9 minus 1 is 8. So plus 8 equals 0. So this is the equation of the perpendicular bisector to AB. So if like we were using instrument, this is what it means. If like we were using instrument and we bisect this side AB, the line that will pass through the perpendicular bisector of AB, this is its equation. So now we are going to do the same thing to the side BC. I have just decided to choose BC. You can choose AC, the same thing, because we just need to bisect any two sides, and when they meet gives at the center of the circle. So I'm just going to bisect BC as well, and then I will use that too. Well, I'm just going to follow this same procedure. I'll find the midpoint of BC. After finding the midpoint of BC, I'll find the gradient of BC. After finding the gradient of BC, I will find a negative reciprocal of that. Then I'll use the midpoint and that negative reciprocal to get the equation of the perpendicular bisector of BC. So that is just what I'm going to do. Since I don't want to be confused, let me write the points here. We start with the midpoint of BC, and that's going to be just using the midpoint formula. Let me just calibrate to avoid any mistake. y1, y2, y2. That will give us -3 plus 5 all over 2 and 8 plus 4 all over 2, and this will give us 2/2 is 1, and then this is 12 divided by 2 is 6. So this is the midpoint of the line AB. Now we need to find the gradient of the line AB, so that we take the negative reciprocal of that as the gradient of the perpendicular bisector. So gradient of BC actually is a gradient of AB, but I mean gradient of BC. Changing y over changing x. This is y2, not y1. 4 minus 8 over 5 minus -3. This will give us -4 over 8, and that will be -1/2. So this is the gradient of the line BC. Its negative reciprocal will be positive 2. So we can just call that M2. We multiply this by this to equate it to negative 1, and we will see that it will be positive 2. Required gradient is positive 2, because when we multiply positive 2 by this negative 1, we will get negative 1, which is the case when you multiply the gradient of two perpendicular lines. So now we are now going to find the equation of the perpendicular bisector by using its gradient and one point on it, which is this point, because the perpendicular bisector will pass through the middle of the line BC. So we are fixing that into the equation of a line when given the gradient and a point on the line, which is y minus y1 equals m times x minus x1. So this will give us y minus 6 equals 2 bracket x minus 1. This will give us y minus 6 equals 2x minus 2. Rearranging all to the right hand side, we are going to get 2x minus y. This becomes 6 minus 2 is 4. So plus 4 equals 0. So this is the equation of the perpendicular bisector of BC. So now that we have bisected two sides of this triangle here, we bisected here, we bisected here, the two of them will meet at the center of the circle. That is the idea. To get the intersection of lines, you just solve the two lines simultaneously to get their intersection. Because I'll be scrolling down, let me rewrite equation 2. But here, I can just divide through, because you don't want to work with big number. I can just divide through by 2 to get x minus y plus 4 equals 0. So rewriting this as equation 1 and 2 so that I can solve them simultaneously, I'll rewrite this one as equation 1. Let me write this one first since it's the one I work first. So x minus y equals negative 4, equation 1. Then 2x minus y equals negative 4, equation 2. With this, it will be very easy for me to eliminate y by subtracting. So I'll do equation 2 minus equation 1. 2x minus x will give us x. This minus this will be 0 already. And then this minus this will be 0. So x equals 0. And we put this into any of them, equation 1. So equation 1 now becomes 0 minus y equals negative 4. And y will be equal to 4. Since this is the intersection of the two perpendicular bisectors, it means that the coordinate of the center of our circle is 0, 4. So this is the center of this circle we have here. Yeah. So now that we have the center of this circle now, we can use the center and any of these 3 points to get the equation of this circle. So that is just what I am going to do. I'm going to fix the center and any of the point. I'll choose the center and A. So I'm going to have my A to be 4, 1, and my center. This time I'm not using C for center again. Maybe let me call the center T, because we already have the point C, 0, 4. Alright. So in this case, I am just going to fix this into the general equation of a circle. Then I get that. So here, this A is the point on the circumference of the circle. So I'll call this one X, and I'll call this one y. And remember, this is negative g and this is negative f because this is the center of the circle. Let's work it and see whether we are going to get this equation here, to see whether we are going to get this, because this is what we are looking for, the equation of the circle. After using the two methods, we want to use a third one to see which of them. So we are fixing this into x squared plus y squared plus 2gx plus 2fy plus c equals 0. Good. We are just fixing any of them first. Any of them. Maybe I want to fix the x first, the center first. So using the center, I'm going to have x squared. Let me call this one equation 1 for easy identification. X squared plus y squared plus 2, our g is 0, x plus 2. If negative f is 4, then f will be negative 4y plus c equals 0. This will give us x squared plus y squared plus 0. Let me just write plus 0 minus 8y plus c equals 0. Alright, now I'm going to fix the point A into it. Let me call this equation 2 again for easier identification. So now say I will put this one now, x equals 4 and y equals 1 into equation 2, and equation 2 now becomes 4 squared plus 1 squared minus 8 times 1 plus c equals 0. So this will give us 16 plus 1 minus 8 plus c equals 0. This is 17. 17 minus 8 is 9. And making c the subject, c becomes negative 9. We put c equals negative 9 into equation 2. So equation 2 now becomes x squared plus y squared minus 8y minus 9 equals 0. And this is the equation of the circle we are looking for, and that is the same as this. That is the same as this. X squared plus y squared minus 8y minus 9 equals 0. That is the same thing we got here. Alright. This has been a very long one. It's been a very long one, tough one. If you're able to get any of this, you have to congratulate yourself for doing very well. And this is where we bring today's lesson to an end. It's been a very tough one, but then those who love mathematics must be a little tough, or tougher than the average person who doesn't like mathematics. So we will just take it like that. But then this is just a little recap of everything we've done in today's study. We're trying to find the equation of a circle when we are given 3 points on the circumference of the circle. So by that, I introduce us to 3 methods by which we can solve this. The very first one is just by substituting coordinates of each of the 3 points in place of x and y respectively in the general equation of a circle to get 3 equations. Then we solve those 3 equations simultaneously to get the values of g, f, and c. Then we substitute them back into the general equation of a circle to get the equation of that particular circle. Then for those who might have challenge with that, we will use another method, which is the center radius formula. And with the center radius formula, this is just what we did. We wrote the equation of a circle in the standard form. Then we substituted the coordinate of each of the points again in place of x and y in that formula to get three equations in A, B, and then R. And then we solve the three of them simultaneously to get the values of A, B, and R. After that, we expanded to get the specific equation of that circle. Then the very last one is employing the idea of geometric construction, where it says that for us to get a circumcircle around a triangle, we need to bisect any two sides of the triangle to get the center of a circle that will pass through all three vertices of the triangle. We chose two sides that we want, and then we bisected those two sides, but we are not using instruments, so we found the midpoint of each of the sides, because the perpendicular bisector will always pass through the midpoint of each of the sides we have chosen. Then after that, we use the gradient of each of the sides to find the gradient of the perpendicular bisector, and then after that we form the two equations of the two perpendicular bisectors, finding their intersection, which will be by solving the two of them simultaneously, and the point of intersection become the center of the circle. After that, we use that and any of the 3 points on the circumference of the circle to determine the equation of the circle. I know it's quite time consuming and then requires a little more attention to details, but when you pay attention, you can solve it. So I encourage you to do more practice, and because I'm encouraging you to do more practice, I'm going to give you some questions for you to look through, and you pause the video, work them out, get the various equations of the circle. You can share your feelings with me in the comment box. The trial question is, find the equations of the circles passing through the points shown. So pause the video, like I said, and work as many as you can, because with mathematics, the more you practice, the better you get at what you are doing. Thank you for making time with me, and I hope to see you again in my study room. Bye bye.